Earth is constantly bombarded by the solar wind, waves of dangerous charged particles from the sun traveling at speeds over 1 million miles per hour. Our planet's magnetic shield, the magnetosphere, protects us from the brunt of this technology-imperiling force. But high above each of Earth's poles, there's one vulnerable spot in this shield, where solar wind is funneled straight down toward Earth and our technology, the polar cusps.
These solar wind energies can negatively impact power grids, radio communications, satellites, and even astronauts, which is why understanding its mysteries and its pattern is key to protecting our future.
To better understand these space weather effects, NASA is launching a new mission called Tracers. The two spacecraft will travel through the polar cusps to take groundbreaking measurements of magnetic reconnection, a process that occurs when the solar wind drags the sun's magnetic field into Earth's.
When the sun and Earth's magnetic fields collide, there's a tremendous energy release. The magnetic field lines snap and reconnect, creating new field lines. This process, known as magnetic reconnection, sends highly energized particles in new directions, including down toward the Earth. Reconnection is very difficult to observe directly because it occurs on small scale compared to the vast size of Earth's magnetosphere.
Magnetic reconnection happens in various places throughout the magnetosphere, but it is most easily studied at the polar cusps. When the solar wind slams into Earth's magnetic shield, it's here at the cusps that the impacts reverberate. By flying through the polar cusps, tracers will be able to directly study the signatures of magnetic reconnection, helping scientists better understand and prepare for the impacts of space weather on Earth.
As we understand that and are able to model it, we're able to get more accurate in terms of how we protect against it and then what we are doing in order to mitigate those risks.
Scientists have caught a glimpse of magnetic reconnection in the polar cusps before, giving us clues about this process. NASA's TRACE-2 was one such mission that launched a pair of sounding rockets briefly through Earth's northern polar cusp in 2018.
TRICE took really good data, one low flyer, one high flyer, and it took a snapshot of the Earth system in one state. It proved that these instruments can make this kind of measurement and you can get this kind of science.
The only thing we could not do with TRICE, of course, was to make the measurement multiple times.
One snapshot doesn't tell you how the whole Earth system is going to behave, particularly under all the variation that the solar wind brings us. A long-standing problem with space physics research is if this is the Earth, you fly a satellite through the physics you're looking at and you see something, and then it comes around in orbit later and you see something different.
Building on TRICE-2's legacy, two Tracer spacecraft will take multiple measurements at the polar cusps by flying in rapid succession, less than 2 minutes apart.
And so with these two spacecraft flying together, we can address this long-standing problem of trying to understand whether the signature that we see of a process called reconnection, when it changes, is that due to something turning on or off? Or is that just that we're flying from one region to another and so we see a change as we transition through that region? People have tried to solve this problem with various combinations of spacecraft, but without two dedicated spacecraft, it remains an open question as to what's going on.
As the two Tracer spacecraft chase each other around Earth, they'll take a record-breaking 3,000 measurements of magnetic reconnection in the first year alone. These new observations will help scientists better understand and ultimately help defend us and our technology from the impacts of solar wind on Earth.
So not only will it get a global picture of reconnection in the magnetosphere, but it's also going to be able to statistically study how reconnection depends on the state of the solar wind. This is going to really help us understand how to predict space weather in the magnetosphere.
If we can understand in these various different situations, whether it happens suddenly, if you have one particular kind of event, it happens in lots of different places, then we have a better way to model that and say, here is the likelihood of seeing a certain kind of effect that would affect humans.
That was one of our final interviews with Craig. Without him, the mission would simply not exist.
Craig Kletzing, the original principal investigator for tracers and professor at the University of Iowa, passed away in 2023. His legacy as a scientist and avid musician lives on through this mission. 2 of his beloved guitar picks have even been integrated into the spacecraft.
So when Tracers launches, there's a little physical piece of Craig, his curiosity, his ingenuity, and his zeal that will go to space one more time.